Welcome to the video. Today we are going to solve minimum element in a binary search tree BST. So in this question we will be given a binary tree and we have to return the minimum element out of that binary search tree. And as you know, in binary search tree, the left child is smaller than the right child. This is the case for every time. Okay. So as we see in example one, okay, we see we don't have to take care of the right nodes. We have to see if there is a left child or not. If there's a left child, we will go down and we will find the lowermost element. So this will solve our doubt. If there is a left child in the binary search tree, given binary search tree, we have to go deeper and deeper and return the last node or the leaf node in most of the cases. Okay, so here one was the leaf node in the leftmost child, and hence we return it. But what if there is no left child? In example 2, you can see there is no left child, only the right child. So as we know that in binary search tree, left child is always smaller than right child. But smaller than what? Left child will be smaller than root and right child will be greater than the root. But what if there is no left child? As in example 2, in that case, root will be the smallest. Root will be the smallest. In example 2, you can see there is no left child, but there is right child. And right childs are always greater than the root. And hence root will be the smallest element. And hence we return root. So with this element, with this knowledge only, we'll be able to solve this question. Just two lines. Let's see. First base condition. If not root, it means if we have came to the leaf node, or if there's no root itself, then we return none. There's no root, return none. Okay, then what if there's no left child, as we saw in example 2? What if there's no left child? If not root dot left, there's no left child. In that case, as we know that root will be the smallest element in that case in the base tree. In that case, we will return root dot data, root dot data. So these were the two conditions. First base condition, second the condition in which there is no left child. But what if there's a normal binary search tree, and in that case you have left child also, you have right child also. In that case, you will go deeper and deeper recursively towards the left child, and at the point when there will be no further left node, you will return root dot data, which means but that particular node's data. So how we will go recursively go deeper to return self dot main value function itself. We'll call the function itself. In place of root, we will pass root dot left. We'll pass root dot left. So we are going deeper in the left subtree. So as you can see, it is able to do the job and pass all the test cases effortlessly and in very less time. So I hope you learned something new and enjoyed it. Thank you. Have a very nice day.